Hello students, the next session in the distributed systems is caching and replication in distributed file system. Coming to the caching, you can do this caching in a client side where we are going to manage all the files in our system and the client system. Whatever the files we required at that moment, we frequently asked files kind of things, we will maintain in the speedest memory, that is a cache memory, right? And the replication is possible at the server side because there will be n number of clients available. All the clients will be asking for same file. Let us assume file F. Now server is having one file, that is file F with it, but client 1 has the same file, client 2, client 3, client 4 and client 5. So everyone started asking same file F. Now instead of wasting time by stopping file sharing to all the files, see one file has asked for read, no problem with that. If you are asking for the read, we can give to all the clients at the same time. If one client is asking for write procedure, we should stop remaining all the processes to hold for a while because we are on the write process which will lock our system. Right. So instead of wasting our time at that moment, so what we will be doing is we will be having replicas of that file F. Okay. So if process A asked, so immediately one replica, process B one replica, process 3 one replica. This will be the procedure which will be taking place at the server side. So thus we need replication at the server side. Done? Now NFS client side caching. Now why we need caching means the cache memory is the speedest memory in the whole memory storages, right? So as we all know about this in our computer organization already. So this cache we are utilizing here for the fastest delivery, the fastest data request or response speed we can call it as. Now our NFS server is ready with the content. Now our client, this is a client machine where my client machine is having the secondary storage, that is a disk, and the main memory storage is a main memory, and along with that we have the caches of those two memories, secondary and the main memory also. Now client application will be always available readily to ask a few files to the server. Now when it is asking for such kind of things, so immediately this client also should be in that speed, right? So for that reason it will maintain the cache memory in that. So this is a small block diagram of NFS client side caching. Now coming to the procedure, how it takes place is client machine will be having one local copy, right? So now client started asking for a file to the server. Now server, it will delegate that file to the client. Now client will utilize that, and client the server will recall for the delegations, and then my file will be updated at the server level. So what is this procedure? So client sends returns file back to the my server contents. So this is the old file. Now client asked for the request. So let us assume my request for the, as a client, my request to the client server is I want a file. So my server will be giving access to me. So what is delegation over there here is, delegation is nothing but giving access right to the file to a client. Okay. So file delegation is nothing but process of giving right action. So whatever the right access I mean to say is, if I as a client, if I ask for read, server will give me read access. As a client, if I have asked for write, then server will be giving me the write access over there, right? So writing and reading procedures will be taking place with the delegation procedure. So server will delegate the file with your requested permission over there. So whatever the permissions we may have to a particular file, maximum to the file we will be having the opening, reading, writing and the executions. That's it, right? Now among this, if we may get any of the delegation file response back to the client. So after that I may have a few requests once again. So my server again delegates me, you can utilize the file for write access or read access. After everything done, done, then my client will be giving whatever the final result file to my server as an updated file. Thus at this moment the old file will be taken out and the new file will be updated here. From there, if anybody asks, if any client asks for that particular file, you will get the updated file over there. So this is what will be taking place in the NFS as a delegation procedure. I mean the callback mechanism is there here and the delegation procedure. So delegation procedure is nothing but giving the access right. So this point is very important in this. Next one is the client side caching in the CODA. So whatever we have seen here is a NFS one. This is a CODA. So CODA is nothing but we have content delivery architecture. So on time, how we are delivering the content to my clients at that moment. So the architecture may be cluster based or is the client based or the peer-to-peer, whatever it is, my content delivery should be appropriate over there. So that is what we are going to do in the client side caching in the CODA, right? Now here, client who is asking for the read operation of that particular file F, my server is readily giving my file to my client. Now my client started utilizing that. Meanwhile, some other client came and B, it is asking for the write procedure. So what we are doing? We are giving a break to the client A saying that we have this invalid callback over there, you just wait for some time. Okay, meanwhile the session has been closed to that particular client. So meanwhile what happens, the file access will be given and you are closing that and at last you are giving the write callback, write delegate to the client B. Now after writing the whole procedure, at this moment if my client A again comes for the open read, okay, then it will show that file transfer, no file transfer, because my file is under updation of the write by the client B. So we should wait over there. Then at that moment, after this closes, the session closes, my file will be given back to the client A as a read procedure. So all these procedures will be taking place in the caching at the client side. Now come with the server replication in CODA. See, server replication is needed, as I have said in the introduction part itself, why we need replication to a server first of all. See, server 1, server 2, so there are n number of servers, right? If any server crashed or else any broken system happens in between the networks, so one side of the network will lose the other side of the content, right? So for these reasons, what we are doing is server 1 will maintain all the replicas of remaining servers along with that. So similarly, either side also the servers will maintain replicas of this content with that. So if anything happens, if any breakages happen also, we will be readily available with the content to all the clients without disturbing our procedure, right? So this is a procedure whatever we are going for, read one, write all. Okay, so in write all indicates that we are maintaining the replica, that's it. Now, here we are handling with the Byzantine failure. So, what is Byzantine failure is nothing but Byzantine failure. First of all, we should know what is Byzantine failure. This is nothing but if a client requests for a particular file, instead of giving the proper file, if you are giving some other file to mislead your client, right? So, all this kind of few frauding things will be taking place. I mean the incorrect data, misleading data, we can say here incorrect, misleading data types, we are giving to the client instead of the correct data. So that is what is a Byzantine general problem which arises. So this we can handle in the CODA content. So here we may have k faulty tolerances, right? If we have 3k plus 1 replicas, we can have k faulty tolerance, because maintaining replicas itself will overload our system, right? So if we started overloading our system, there will be a chance of getting misleading or incorrect data, obviously. So for that content, what we are saying is 3k plus 1 replicas if we have, we can get k false, obviously. So for that we will be always readily available to tolerate that one. So fault tolerance is very important here. Now here all these are replicas and this is a master one and this is a client. Now client started asking for one content to its server. Now server responded, and along with this client is requesting to all the replicas also. Now from master, all the replicas will be enabled over there. Now all the replicas will give back the content to the master over here, right? Now here master is again asking for few data. Now replica 2 is having the data, so it is giving back to all the client, all the master and all its colleague replicas over there. So like this, see, every replica is giving its content to the master and its peer replicas. So this will be taking n number of phases for the Byzantine failures. And the last but the least, security in NFS. Security in NFS is handled by only one procedure. So this is a NFS structure. Already we have seen in the previous sessions where we have discussed about the architecture. So here we have all the things. So virtual file system will be there and access control. This is the interface which will be holding all the local file system with us, and NFS client will be having the hold on the client data, and whenever it started asking any data to the server, the RPC client stub will be readily available. What is your request? I will marshal it and I will send into the network. And at the server side, I will receive the marshaled data. I will open that with the decoding procedure. Marshalling is nothing but we'll encoding. Okay, we'll unmarshal that and we will see what is the exact request given by the client. Then we will process it with its existing file system. Then it will give the give the response in the same manner, right? So the only difference which we can see is here is a secure channel. Instead of network here, general network, we have secure channel. The channel itself is briefed with the security procedures. Next, secure RPCs. See, in the secure RPCs, we have the client machine and the server machine. Here in the RPC client stub, we have a framework. We have to say as a framework. So now in this framework, we have RPC security by GSS, generic security service. Okay, so this generic security service is an API which enables internally, libkey and also the Kerberos, and whatever the certifications and all we required will be enabled in this. Okay, so LIP key is nothing but a low infrastructure. So with low infrastructure public key, we will enable this one, and Kerberos for all the authentications purposes. So like this, we will enable whatever the required things to that particular framework will be highlighted over there. And whatever the control accesses we can have over here is owner is nothing but to a file. See, we are discussing to a file. Owner is nothing but who created that particular file group of users who are associated with this. All these are basic file system attributes we can say, and everyone can access the file. Interactive, who has given the permissions can interact with that, the limited people. Next, network, to a particular network we can give the access. Dial up, any processes accessing the file. See, who is asking for that particular access, we will give access to that particular, on the dial up, on demand we can say. So batch is nothing but a group of processes we can say. Anonymous, this is very, very important. Without authentication we are going to give the accessing. So in this we have to think a lot while we are giving the access. Authenticated, obviously who are the authorized users can be getting the chance to utilize that. Service, any system defined service process. If any system application require that particular file, so as a service we have to provide that file as a input, right? So there are a number of access controls over there, but the only thing we have to think among this is a anonymous one. So if we have internal frauds means anything is interactive, while batch wise and network wise also we can get a number of security issues over there. And the last one is a collaborative storage. See how we are going to store the data in a proper way in a collaboration with our peer entities, right? So here P, Q and R are three storage peer systems. Now P has F, Q has G and R has nothing in that. Now we are going to save, see whenever the request comes to particular queue, it started asking the data. So from whom? The peer entities. Now we are going to maintain F in the queue and G in the R. Now what is the total storage of this one? Is a queue, which is the size will be what is asked by the queue. So queue size will decide overall storage we need for particular file system, right? So this is all about the security and also the total file system concept here. We have discussed about the caching and replication here. So if you have any doubts in this, please feel free to contact anytime in the college. Thank you.